All right, so let's start section 6 here. This section is one of the more algebraically intensive parts that you need to know. And if there's ever a question on how I got a number, it's probably because I know what it is, and you can find it just by plugging it into a calculator. So any numbers that you don't understand how I got, just follow the algebra, plug into your calculator, and see if that's the same number I got. Okay. But here you need your normal strategies like FOIL, you need your distributive property, your box method, whatever it is. So here you have to look for extraneous solutions. A solution is extraneous if it is the result of proper algebraic work, yet in the end, when it is substituted into the original equations, both sides are not equal. So it is not a proper solution, which is why we say it's extra. It comes from algebra, but it's just extra and doesn't work. Alright, so here for type 1 problems, you just use PERMDAS. So here we have that 3x plus 1 in parentheses. We have the minus 4 in the end. And we have that radical, which is a square root. So first off, we add 4 to both sides. That gives the square root of 3x plus 1 equals 5. Then we square both sides to get us 3x plus 1 equals 25. And if you solve it out, you get x equals 8. Down here, same sound, different verse. So this is, and then here to check for extraneous solutions, all you do is you plug it back in. And so I'm going to get a little bit lazy here. This is the square root of 3 times 8 plus 1. There's a minus 4 on the outside. I know that this solution works. So it's equal to 1 on the left side, equal to 1 on the right side. So x equals 8 is a valid solution. It's not extraneous. Here we subtract 16 from both sides. You get that the fourth root of 2x plus 5 is equal to negative 9. Remember here, if we set up our PERMDAS, we have 2x plus 5 here underneath that radical. We have a fourth root. We have a plus 16. So we've already gotten rid of it by subtraction. We raise this to the fourth power, which is a big number. It's 81 squared and 64, 61. 65, 61. This is 2x plus 5. You subtract 5 from both sides. You got that 2x is equal to 65, 56. Divide that by 2. 6556 divided by 2 gives us 3278. And so if you plug it back in, let me use the stow button this time. 3278. Let me store that into x. And then we can just check that the fourth root of 2x plus 5 plus 16 is equal to 7 or not. And it's actually not. And so here, this is not a valid solution. It is extraneous. And so this problem here does not have a solution. It has no valid numbers that can be plugged in to get the right-hand side equal to 7. When you are solving with radicals, you exponentiate both sides to the reciprocal of the power shown. So the power that we have here is 2 over 5. So what we do is we take that expression on both sides and we raise both of them to the 5/2 power. The reason being is that remember that there's a property here that says a to the b to the c. You're going to multiply those two things, those powers. And so when you multiply a fraction and it's reciprocal, you always get 1. And so this leaves us with x plus 3 equals, and this one happens to be 32. You subtract 3 from both sides, and you get x equals 29 as your final answer. So let's just check that one here. So 29 is going to be stowed into x. And then let's just check that x plus 3 to the 2/5 is equal to 4. It is. And so x equals 29 is our valid answer for that problem there. Okay, let's keep going. The next part here has variables on both sides, and it's pretty okay. And the last part here has 2 radicals. And then here's just some extra practice problems here if you'd like to do that. Okay, and so, well, let's just go. So type 2 here requires that you isolate the radical. You square both sides. And you solve the remaining quadratics. You check for extraneous solutions. So the first thing that I notice here is that this problem is dumb because it has a lot of fractions. And so one of the things I can do optionally is that I can simplify the square root here. So I can reduce this problem down to x minus 1/2 equals 1/2 times the square root of x. So basically I just split up this product on the inside with the 1/4 here in the x, and the square root of 1/4 is just 1/2. And I'm doing this because now I want to get rid of that fraction, so I'm just going to times 2 by everything. So this gives me 2x minus 1 equals square root of x. And so in 2 steps, 2 really short steps, I can get rid of those fractions pretty easy. So on step 2 here, I'm going to square both sides because the square gets rid of that radical. But the cost here is that this becomes now 4x squared minus 4x plus 1. This is just to become x. And so this is 4x squared minus 5x plus 1 equals 0 when I subtract x from both sides. And so I believe the factorization is going to be 4x x minus 1 minus 1, it is, equal to 0. And so your answers are 4x minus 1 is equal to 0 and x minus 1 is equal to 0. You split those bad boys up and you solve for them separately. X equals 1/4 is one of them. Adding one to the other gets me x equals 1 as the other solution, and there you are. You're done. This problem is hard in a couple of spots. See, I'm good at doing factorizations like this. The alternative that you can do if you really wanted to was use a quadratic formula. So that's negative b plus or minus the square root of b squared minus 4ac all over 2a. If you don't like factorization like that, then I would recommend that you should definitely learn the quadratic formula by heart. And that'll still give you these two answers, 1/4 and x equals 1. Now the issue still remains. You still have to plug in these answers back into the original. So don't forget to check for extraneous solutions, because this is always one of those things that's there. Okay, and so the stow button is going to be my friend today. So 1, stow that into x, and let's see, x minus 1/2 equals, oops, is 1/2, and then the square root of 1/4 x is also 1/2, so both sides are equal. And so this one on the right hand side is good. Now I can take 1/4 and I can stow that into x, and I can just check both these expressions on the left and on the right hand side. Nope. One is negative, one is positive, and so this one here is not a valid solution. You have to mark it as extraneous. And so now you're done. Last but not least, each radical must be on its own side of the equal sign. You square both sides. If there is a radical remaining, you square it again. And it becomes just like the last problem type. Now, what I'm appealing to, and especially with this expression right here too, is there's two formulas that you should really know. And it's the perfect square trinomial formulas, which I do kind of fast. But these are the two formulas that really help you, especially when it comes to simplifying these expressions and making these problems a lot easier and less, I guess, algebraically intensive. And so it makes them less scary. And so here, square that side, square this side. The right-hand side, because you have a radical there, is just killed off by that square. On the other hand, this +1 here means that we have to FOIL that out. And once you do FOIL it out, and I recommend you use this formula here, you have x + 2 plus 2 square root of x + 2 plus 1. And so all in all, this is x + 3 plus 2 square root of x + 2 equals 3 minus x. So here, subtract x from this side, minus x from that side, minus 3 from this side, minus 3 from that side, gives you just negative 2x squared. I'm sorry, just negative 2x. So now that these have canceled out on the left-hand side, you're just left with 2 square root of x + 2, at which point, let's just divide by 2, so that you get square root of x + 2 equals negative x. Squaring both sides gives you x + 2. Again, the radical cancels on the left. And then if you were to do the quadratic formula, you would need 0 on both sides, one side. And you would need your x squared positive, generally. And so I just know that this factorization is x - 2 times x + 1, and so my answers are 2 and negative 1. This is just me factoring, but again, the quadratic formula is a viable tool. One last time, you do have to plug these back in. I believe that when you do, actually I don't know. So let me not say anything. So 2, store that into x. And so square root x + 2 plus 1 is 3. The right-hand side is square root of 3 minus x. So see here, this is 3, this is 1, so they're not good. And so my number for 2 is extraneous. Let's try negative 1. Stowed into x. Oops. Negative 1 stowed into x. And then see if these two expressions work out. Yep. And so here, negative 1 is going to work for us. And so 2 here says to be extraneous. So our entire solution is just negative 1, but while I'm checking your work, I'm also wanting that 2 as extraneous as well. So you can stop here now if you are okay with all of the notes. However, I'm going to go over the next extra practice problems, but again, these are optional, okay? if you square both sides here, you get 10x plus 9 equals x squared plus 6x plus 9. So the 9s are going to cancel, and eventually you get x squared minus 4x equals 0, and that factorization is x times x minus 4, so your answer is going to be 0 and 4. Both of these are going to work out. I just did that in my head, it's fine. But 0 and 4 are going to work out. None of those are extraneous. Same song, different verse. This one's a lot harder, it looks like. You're going to square these two. So that gives you x plus 6 plus 2 times square root of x plus 6 minus 2 is equal to x minus 2. I'm sorry, plus 4. And so here, your x's are positive, so those are going to cancel out. You have 10 plus 2 square root of x plus 6 equals negative 2, and I bet you there's no answer. Minus 10 and so x equals 30, we do get a legitimate answer. The only issue being that when you plug it in, you're not gonna get, if I have it my way, the same two numbers. Hello. Oops. See? One is 5 point something something, one is 4. And so here x equals 30 is extraneous. And if your only algebraic solution is extraneous, your overall problem has no solutions. And this here concludes the video. Make sure you do your reflection questions, but this also includes a unit as well. Nice.